Guys, I managed to get to BenQ to save our notes overnight. So, we left off working on 4A.
Yes.
I believe I asked you guys to finish that. Did you finish that by hand or did you put it in the calculator?
I put it in the calculator.
Put it in the calculator, okay. And you know what to do, right? You would evaluate it for 7, subtract, and evaluate it for 1, subtract those values, right? So, okay, what do we get when we put this in the calculator then? Negative 6.
Meters.
I don't think it's meters though. Oh, it is.
Meters.
Huh. So, yeah, I wrote feet in my, which is why I thought it was feet, but it does say meters up here. Okay, so that is a negative 6 meters, which means what?
We're 6 meters to the left of where we started.
Right, to the left. So just realizing because it's negative, that is, 6 meters to the left. Okay, so that was the particle moving along the x-axis. It was the given velocity and the initial position of negative 3. And so we looked at displacement. Displacement was from time 1 to time 7, what is basically the change in position. And that change in position is 6 meters to the left. Now B says what is the total distance traveled by the particle on that interval of 1 to 7. Now if you go back and look from the other day, displacement is just the integral. Total distance is officially the integral, of the absolute value. So it would be the integral from 1 to 7 of the absolute value of v of t, dt. Now that's official. What's the catch here? If it says absolute value, we need to know, we need to do them all as positives. Is there any piece of this graph that is below the x-axis that would give a negative value? And yeah, there's going to be, okay? So with that in mind, we need to take this 1 to 7 interval and break it up into our pieces, okay? We're breaking into the pieces that are above the x-axis, which are already positive, but then the pieces below the x-axis, that's where the absolute value matters, because we'll have to make them positive. Now, ways to do this. My suggestion is we look at the graph. Okay, or I guess you can look at a graph, or you can look at it algebraically, because, so what are we doing here? We're doing the integral of 1 to 7, and if we look at the function, it's going to be the absolute value of negative t squared plus 7t minus 10 dt. Well, it's not that we just change everything to positive. That's not how it works when you have variables in there. Two different thoughts. One I can look at, actually, okay. So, I guess it would come down to, do you have a calculator on your side on this problem? I mean, obviously we do study in this class, but talking about AP testing, is this on a calculator or non-calculator portion? Because if it's on a calculator portion, can you really easily just throw this in the calculator, graph it, and see what it looks like? Piece of cake. If it doesn't, okay, we know this is an upside down parabola, yes? Can we find the places it crosses the x-axis? The zeros. Yes? So if I'm going to find the zeros, me personally, I don't like that negative there. I'm going to factor it out, divide it out, do something with it. So I'm going to have, if I get rid of that negative, it's t squared minus 7t plus 10. That looks pretty nice to factor, doesn't it? So that's going to factor, let's see, t and t. What are my numbers I need? 2 and 5, both negative. Which means when I set these pieces equal to 0, we're going to end up with t being +2 and +5. Now, so visualize, what's this graph looking like then? My parabola is going to, it's a negative, so it's an upside down parabola. And I don't know how accurate that is, but what am I trying to show? It crosses the x-axis at 2 and at 5, correct? But what interval are we on? We're in the interval from 1 to 7. So we really have to go from 7 to 1. And this has the tagline of not drawn to scale. Okay? But here's the deal. What are the intervals I'm going to have to break this integral up into?
1 to 2, 2 to 5, 5 to 7.
Right? Because when we look at, let me find a different color here. The integral from 1 to 2, that's going to be that little piece right there, isn't it? That's going to come up a negative. We need to do the absolute value and do the positive. 2 to 5 is going to be this piece right here, and then 5 to 7 is going to be that piece right there. So we've got a negative, a positive, and a negative. So I'm going to break this integral up into the integral from 1 to 2 of the absolute value of v of t dt plus the integral from 2 to 5 of the absolute value of v of t dt plus the integral from 5 to 7 of the absolute value of v of t times dt. And I would say grab the calculators or do it by hand, whatever makes you happy there. Grabbing the calculators definitely sounds more interesting on this one. Although I did just treat the graphing portion as if we don't have calculators, so.
It's okay, just
it's okay?
Yeah.
You won't be too mad at me?
No.
Okay. Now the nice part is you can copy and paste your integral over and over and just change the boundaries, yes? Now, you do not necessarily have to put the absolute value bars in your integral. And in fact, I'm not sure, does it mess it up if you do?
I don't know, I put mine in.
I'm going to be curious how this turns out.
No, just as long as you recognize that it's.
Yeah, and for me, that's what I do, is I just did each of these integrals by hand, or not by hand, but on the calculator. I didn't put absolute value in. I just know that, okay, on the first one, 1 to 2, I'm going to get a negative, aren't I? But then I need to turn around and make that positive. Are we getting any of these values?
Can you have?
I will say mine are in fractions. Which remember, if you go into Math Menu, you can always real easily turn a decimal into a fraction.
Excuse me? Much better.
My fraction button doesn't always work. It just sometimes, most of the time, just gives me back a decimal.
Well, if it's giving you back a decimal, that means it can't go to a fraction.
Well,
But that can go to a fraction. Yeah, if it just gives you a decimal back, typically what it is it can't get to a fraction.
That's what I'm saying.
But I know that can't get to a fraction. I'm not sure why it's doing that.
¿Y cuántos años tienes?
Oh, maybe because it was an integral.
El quinceañero.
I don't know how the calculator does the rounding in an integral, so. Okay, what kind of values you guys got?
Quince.
Do you want individual ones or
Individual first, yes.
the first one? I got 1.833.
Okay. And now, and I will say in my notes, I have it written as a fraction. And so when you do this on the calc there, you get either negative 11/6 or negative 1.833333, right? But when we do the absolute value of that, we're going to do the positive of that, right? Okay, plus, what do we have from 2 to 5?
4.5.
I heard cacho. I got that's 4. I'm lost after that, so. Okay, so 9 halves are 4.5. What is it?
26
Yeah. Comes out to be negative 26 over 3. Yeah, and I don't know why they're not turning to fractions. I don't.
Okay, wait, let me try
So
this.
then at that point, do we just have to write the decimals?
You go with decimal. And here's the deal. You don't even have to write the individual pieces necessarily.
Yeah.
What is this one as a decimal? It's
8.6.
Yeah, mine's not going either. It's fine.
I don't know how you
Yeah,
do
mine.
and I don't know why it's not going because it should.
Oh,
Mine did.
Well,
Mine didn't.
mine didn't.
Maybe it's a,
8.666 number?
is it a mode?
Yours went to a fraction? Yours
Are
aren't.
we in the wrong mode? Is that the
Well, it's also like your preference. You can set it to spit out a
Nope,
decimal
still
first
doesn't
or
work.
fraction first.
How the heck
I have
do you
answers
do
to
that?
this.
Okay, guys. What do you get when you put all this together?
15.
15.
Assuming that means that it's
Okay. And I don't even really. This is 15 what?
Meters.
15 meters. I was at least consistent in my notes. I have 15 feet again. I kept the whole problem as feet at least.
Yes, sir.
I'm not sure how I did that, but
If you were the all those decimals just turn exactly 15.
okay.
You know what? That's kind of funny.
Are we ready for example 5?
Yep.
Keep laughing.
I am.
Suppose you are driving in traffic behind a large bus at 66 feet per second. This is 45 miles per hour. So nice of the prompt to tell us this. When you finally get a chance to pass, you step on the accelerator, giving the car an acceleration of 4 over the square root of t. Okay. Where a is measured in feet per second, and t is measured in seconds. Okay. How fast are you going 16 seconds later when you have passed the bus?
a little faster.
What'd you say?
A little faster.
A little faster. I'm sure that is a perfect calculus answer, and they'd love that.
Don't we have to do the
Yeah.
integral of accelerations to get velocity?
Yes. Okay, so we are going to have to start with the fact that in order to find velocity, which is what we need here, we need to do the integral of acceleration.
That is a very strong sound.
Okay. When we do the integral of acceleration, we're doing the integral of 4 over square root of t, which I'm personally going to write as 4t to the negative 1/2 dt. Integral of 4t to the negative 1/2, or just forget the 4 for a moment. What's the integral of t to the negative 1/2?
T to the 1/2 times 2.
You add 1 to the power at 1/2. Dividing by 1/2 is multiplying by 2. So we're going to have the 4 that's already there times 2t to the 1/2. And then what can we not forget? Plus c. So we have 8t to the 1/2 plus c. Or if I go back to square roots, it's 8 square root of t plus c. Now, for the c value, what information do they tell us that we can use to find c?
Start at 66.
Okay, right? So we are starting at 66. Okay. Yes, and our acceleration was measured in feet per second. So we want to keep it, we want to use the 66 feet per second. So this is the idea of saying the velocity at 0 is 66. Okay? Does that? So now, if we input 0 here, I'm trying to, have I done this lately? Do I need to show the math? I mean, if I say, okay, v of 0 is 8 square root of 0 plus c, and that equals 66. What do we know c is? 66, right? Which often happens. And you'll see that a lot where the work's not really shown. We can just go ahead and say that c ends up being 66. So my velocity equation is 8 square root of t plus 66.
When can you not assume like that C value? But at some point we couldn't assume that was the right C value.
The time you're thinking of was when we were using our exponential growth, and it was that CE to the KT.
Oh.
We can here, but if you had anything different, like, you know, an extra piece added or subtracted or anything different, you couldn't. Okay? Now, on something like this, if it's at time 0,
Yeah.
you can usually assume that's your initial. You can usually assume that is your C value. But I would always do a quick visual. If I plug 0 in here, will everything disappear? Because if there's something that won't disappear, you know, for instance, you have like a natural log, which natural log of 0 is not 0, that type of thing. Okay, what are we even supposed to be doing here? We found this lovely velocity equation.
16.
Yeah. How fast are you going 16 seconds later? So we are putting in a 16. So 8 square root of 16 plus 66. So whatever 32 plus 66 is?
98.
98 what? Feet per second? Okay. B. How far did you travel during that time?
Integral.
So we're doing the integral from 0 to 16. Officially, it's how far did you travel during that time. So that to me says total distance, yes? So that to me says it's the one that's the absolute value of v of t dt from 0 to 16. Now, when we go to do this, wait, I'm going ahead of where we go to do this and we're trying to figure out, okay, can we do 0 to 16 all at once? Do we need to break this into pieces? Here's where, okay, what is v of t? It is this 8 square root of t plus 66, right? Can you visualize that graph? What do Ethan did? That was his. I can't, you know, I can't do it as well as Ethan. Jake's gonna add extra sound effects for us. But, and here's the deal. Multiplying by 8 is gonna stretch that graph up. Adding 66 is going to raise it. Is there gonna be anything below the x-axis? No, because you're basically gonna have a half a parabola that is stretched and raised. So, do I need to break up my interval here? No, but did I check into the situation?
Yeah.
Yes, and that's what you have to do every time. Okay?
So because there's a square root, we know it's a parabola on its side.
Yeah, our square root graph, like the y equals square root of x, just nothing fancy whatsoever, is the top half of a sideways parabola.
Is that an exponential graph too?
Not exactly, because exponential graph does, well, I don't know. It does this. It runs, so square root graph ends at 0, 0. Exponential graph runs down like an asymptote. And I don't know, they don't necessarily cross like that, actually. I might have that backwards. So similar, but yet no. Okay. Integrate? Yes? I think I did a crazy thing and integrate by hand.
Whoa. Party foul.
Oh, well, I guess it's not that
8 square root of t, so that's going to be 8. If it's square root of t, that's t to the 1/2.
8 times 2.
Yep. Add 1 to the power, it's 3/2. Dividing by 3/2 is multiplying by 2/3. Plus, the integral of 66 is 66t, evaluated from 0 to 16. Okay. Let's see. 8 times 2/3 is 16/3 times 16 to the 3/2. Well, that is the square root of 16 cubed, isn't it? Plus 66 times 16. Oof, big number. That's the first part when I plug in 16. And then what happens when I plug in 0?
Everything's
And did you double check that, though? You're not just assuming, oh, it's a 0, it doesn't matter. Do a quick visual, right? That is going to be minus zeros. So the square root of 16 is 4. 4 cubed is 64. Times 16 is some number that's not in my brain. A number that I don't have written down in my notes. This is the last step I've written down in my notes. Then I go for the answer.
24.
So, what was it?
1024.
Okay.
Now I'm getting fractions.
What?
Now I'm getting fractions.
I got fractions.
Okay, well,
Give me 65,536 over 3.
I would turn that to a decimal, please.
I'll see if I can. It just keeps getting a fraction down.
But if you go into math menu and go to like number 2, it should show it as a decimal.
Yeah, mine still
Okay,
won't
and if
switch
I
to a
divide it by
fraction.
3, then
So if you would have like done that,
if I
and
do-
then it won't like if I pick that,
Honey, what did you
because that's how I would do it.
That's-
But your dividing works too.
So if I do that,
345.
okay.
45.
For a final answer,
Is that right?
not what I have written down.
I got 1,396.
That's the final answer I have written down.
See, when I did
With
this
a
one, it
.333.
Yeah.
Jakey, you said yours spit out a fraction?
Did you type in a fraction?
Sometimes it enters. It depends on how you enter it.
Yeah.
Either way, I did something wrong.
Oh,
I, I forgot to cube this.
We just plugged it in. But when I did it by hand, I got a weird answer.
well, it's because you have a fraction
Yeah.
in your multiplication versus when you just do an integral.
Okay, are we finding our mistakes?
Always was the surgeon.
And we're learning how to use calculators again, I guess.
Mine still won't give me fractions.
Okay. So keep in mind, this right here was total distance. Okay. And I'm ready for C when you're ready for C. I feel like we're taking forever on these examples today, but although, ooh, we gotta move. So I got a page and a half here. Okay, C. What is your average velocity for the 16-second interval? I have 2 different ways we could do this.
Did you final velocity minus initial velocity divided by 60?
Is this the one?
I guess you could think of it that way, in a way. But
Wait, so we're telling
Try to think. There's two different ways we can do this. And I just looked at, well, maybe more than two different ways, but what do you guys say?
Oh, I was gonna say, is this like the last lesson where it's like you put the whole integral and then it's over b minus a?
You can't do that. And this is where I say there's two different options, okay? Average velocity. So we can go back, and now we're going to be repeating work if we do that. But we can go back and do the whole idea of 1 over 16 minus 0 times the integral from 0 to 16 of v of t dt. However, do I want to redo all that work? Because what do we already have?
That.
Isn't this going to match up with this? I know we had absolute value earlier, but did we even need the absolute value? No, we had to think about it, but we didn't even need it. Okay, so this is a situation where your displacement and your total distance are going to match. They're going to be the same. And so you can go ahead and just take this and make it the 1,397.3333 divided by 16. So, in other words, whether you use the concept of average velocity, like what we learned in the previous lesson, or whether you just use the idea of total distance divided by time, or displacement divided by time. Both work here. Okay, so what do we have? 87 with a whole lot of threes. And that is going to be feet per second.
What I said doesn't work. So
Okay.
I got 2. So.
Yeah, definitely not two.
FPS is also. It's also frames per second.
Okay, so yeah, and in this case,
It's also for FPS.
you could have also done just, well, I wrote displacement. I could have also wrote distance, but displacement divided by time, or distance divided by time. Okay. We good? Okay, moving along. We've got a half-page problem and a full-page problem. Okay. You drop your calculus book from a window 48 feet above the ground. Because why not?
I can do this.
How long will it take your book to reach the ground? Okay, well, let's gather some information. What do we know?
It's 48 feet above the ground.
Okay, so that 48 is my initial height. So I'm going to say initial position. And so I'm going to say S of 0 is 48. If you remember, we sometimes use S of t or X of t. So that is my initial position. What else do we know?
Gravity. Is it 16 feet?
Oh shoot, it's the Pete one. Yeah, I know.
Is that
Okay.
the one? That's the one that was
That was in the
But, so
32 something.
32. Yeah.
So you're doing 1/2 of that one.
Exactly. Yeah, I know. Okay, so first of all, you do have to notice this is 48 feet. So we're not talking 9.8. We're talking 32. So if we talk about our acceleration, if you will, and because we're talking gravity with, it's the gravity force, so acceleration is negative 32. Okay? Which you guys don't use that one much in physics, do you? Yeah. Okay, you will see it pop up in calculus, though. Okay. What do we know about our velocity? What is your initial velocity? 0, yes? The velocity at time 0 is 0 because you are just holding the book, yes? Okay. So we want to know how fast we're going. No, how long it takes the book to reach the ground. Sorry, jumped up to the wrong problem. So what do we need to find?
Time. No. Yeah.
Eventually time. And it's eventually going to be the time of when the book reaches the ground. So eventually we're going to be looking for S of what equals 0. That's eventual, yes? What do we have to do first? Well, before we can get a position function, we have to get a velocity function. So what do we know about velocity? It is the integral of acceleration. So that means it is the integral of negative 32 in this case. What is the integral of negative 32? Negative 32 plus c. Now, I will say on some of these, yeah, you can grab it. It's over behind my desk. Huh?
Is that on your desk?
No, it's just right over there behind my desk. Okay. I will say on some of these as you're going through today, you might want to use like C1, C2, C3 because we'll have multiple different constants within a problem. Do we on this one? We kind of do. So it just kind of depends. A lot of times one constant will drop out before we get the next constant, but you'll run into some where we have multiple constants within the problem. So, okay, how do we find C? What do we know? Yeah, we know that V of 0 equals 0. So basically, what does that tell me? C of 1 is 0, right? You don't necessarily have to write that math out when it's an obvious one like that. So that just makes my velocity function negative 32t. Now, what do we find after the velocity function? Position. And position is the integral of velocity. So that means position is going to be the integral of negative 32t dt. Integral of negative 32t. Negative 16t squared. Add 1 to your power, which makes it 2. Negative 32 divided by 2 is negative 16. And notice I said plus c again, right? Officially, it's a plus c2 at this point. What is that constant going to be? 48. Because when time is 0, my height is 48, yes? So if you want to go ahead and just write, and you'll see this done in the notes a lot, just that it's going to be negative 16t squared plus 48, that's fine. Don't do that, though, if something the 0 is going to make something happen. Okay? But this is officially as you're plugging in 0. And so we know c is 48. So my position function is negative 16t squared plus 48. So we got a position function after we found a velocity function. I say, what were we doing? I don't even remember at this point. We want to know, when does position equal 0? So this is the idea of taking s of t and setting it equal to 0. So negative 16t squared plus 48 equals 0. Move one of your pieces over to the other side. And I'm going to make them both positive in the process. 16t squared equals 48. Divide by 16. I believe that's 3, isn't it?
Mm-hmm.
And then t is the 1.7 what?
3-2.
Okay. Actually, you know what? In my answer key, I just left it a square root of 3. Totally not against the 1.7 type number. Prank call. Okay. And that is in terms of seconds, yes? Put the decimal, don't put the decimal. Doesn't matter to me. I never wrote it. Why did I never write plus or minus?
Time.
Or with time, yes. Okay. Okay. What is the velocity of the book at the instant it reaches the ground? And what is our t value? Square root of 3. Now this is where you should use square root of 3 to plug it back in. That's going to be your best bet as opposed to the 1.7 whatever number. Okay? Not saying that was the wrong answer earlier, just plugging back in, go for precise. So velocity of square root of 3, plug it in. Only got negative 32 square root of 3. I know that part without grabbing anything. Which is what? I've written down negative 55.426, going 3 decimal places, and that label would be feet per second. Okay. One more page. I will say, you know how some of these problems are kind of taking a bit, yes? I felt like homework did the same thing. Okay, so just kind of beware. What does he want a picture of?
The board, because I didn't do it, I just plugged it into kinematic equations and did it that way.
So you did it the physics way instead of the calculus way.
I got the same answers, Mrs. Sargent.
Now, and I'm not going to argue
I
that.
love looking how it like adds up though, because like if you look at each integral like step by step, it becomes.
It becomes what? And it's cool to see, but here's the deal. What are they going to want to see on AP Calc?
Yeah.
They're not going to want to see your physics ways. I don't think they would give you credit for your physics ways.
Yeah.
Now, it's good that they are working out to be the same. It shows that Mr. Kevin and I aren't teaching two totally different things. You know, I mean, in the end, it does all meet up. But, yeah. And here's the deal. When I grade your calculus test, I'm going to expect to see the calc ways, not go ask Mr. Kevin if this makes sense or not, you know. Okay, number 7. A particle moves along the x-axis so that its velocity at time t from 0 to 15 is given by the differentiable function v. Huh? Oh, calculator return. His graph is shown below. At time t equals 0, I'll take him.
I don't remember how many, so
There should be 11 total. Jonathan brought his back.
6, 7, 8, 9, 10, 11.
Which he did because he took
Okay.
the pink one. So.
All right, we're good then. Thank you.
Thank you. Okay. I don't even know where I was in reading, but a couple of key things. At time t equals 0, the particle is at x equals 4. Yes? So right there, that's giving me an initial. Okay. And so I know, I think I used x on this one. Mainly, I don't know, was there an x there or did I just pick to use x? Who knows? The velocity is 0 at t equals 3, 9, and 13. Does that make sense? If this is a velocity graph, velocity is 0 at 3, 9, and 13. That matches up there. The graph has horizontal tangents at 6 and 11. What are they telling me there? Slope is 0. And so that's telling me specifically that there is a min and a max at those respective points. In other words, at that point, they're specifically the 3, 9, 13, I was pretty confident on. The min and max, it's nice to have the reassurance that those are the specific points that they do occur at 6 and 11. The areas of the regions bounded by the t-axis and the graph of v on the intervals. And that is these numbers written in here. So this 6 is the area for that section. 9 is that piece below. 3 is that piece here. And this 2 is the piece from 13 to 15. Okay? That's what we got. A. From 0 to 15, find the time and position of the particle when the particle is farthest to the right. And we've seen a lot yet lately, haven't we? Justify. In other words, don't just give me an answer.
Can't you do 4 plus 6 minus 9 plus 2 minus 2?
Okay. Sorry, I was struggling with. When was it making sense for a moment? Got it. Okay. With this, we want to know when the particle is farthest to the right, yes? So, at what points or when are we moving right? Above the x-axis, yes? So, from 0 to 3, we're moving right, yes?
Mhm.
Then we move left, and then we're moving right again, and then we're moving left. So there's two different places we have to check and see how far right we are. Does that make sense? We need to figure out our position at x of 3, and we need to figure out our position at x of 13. In other words, which one are we farther right at? Now, what do we have to take into account here? We had an initial position of 4. And if I write mathematically, it's 4 plus, here would be 4 plus the integral from 0 to 3 of v of t dt. However, what's the basic math you're doing here? It's not like we're actually doing an integral. We just do 4 plus 6 and get 10. Are we okay with that?
Then the other one, 4 plus 6 minus 9 plus 3.
Yep. So the other one, because there's no point to check at time 9, because we've just taken the time at the position at time 3 and moved left. So there's no point to check there. Okay, so now from 0, if we do the 4 plus from 0 to 13, it's plus 6 minus 9 plus 3, which puts me at 4. So, find the time and position. What do we know? The particle is farthest right
At time 3.
at time t of 3, and at that time it is move 10, yes? Okay. Now, as part of a justification, we've shown our work. The other thing is that we need to at some point mention, and why did we check at 3 and 13? Because that is when our velocity was positive, right? So I am going to say velocity was greater than 0 on 0 to 3 and something to 13. 9 to 13. Okay? So as part of my justification, particle is farthest right at t equals 3. I'm going to say when x of 3 equals 10. Okay. B as soon as you can. I'm going to run out of time. I thought I had plenty of time. For how many values of t from 0 to 15 is the particle at x equals 4? Explain your reasoning. And this is where I ended up doing a table, so to speak. And I think what do I have on the next page? Okay, we need the graph to do this. So I'm going to put my table, I'm going to do a table, but I'm going to put my table for part B right here because you guys can put it down on B. I just don't want to go back and forth. But if we look at a table here, because we want to know how many times is the particle at x equals 4. Well, we need to look at the time versus the position, right? At time 0, what's our position? 4. Then the next time, at time 3, what's our position? 10. At time 9, what's our position? 1. At time, where am I at? 13. At time 13, what do we do? Just add 3, so we're at 4. And at time 15, we're at 2.
Do you only have to check those values?
Those are the only values we really can check. But here's the deal. What we have to consider here is that this says it is a differentiable function. Go back to first semester. Differentiability means that the graph is continuous. If this graph is continuous, it doesn't just jump from 4 to 10, does it? It hits every value from between 4 and 10. It doesn't jump from 10 to 1. It hits every value, including, there's a 4 in there, isn't there? So there's a 4 here. There's a 4 in that interval. And there's a 4 here. Are you seeing where I'm going with this? So 3 times. It's not just the fact that 4 appears twice. It also passes through 4 at another point. And that is because it's differentiable, we can know it is continuous. Okay? Now, I would have this information down on B. Let's see. I did, because it's going to say justify, right? Oh, excuse me. Explain your reasoning. I did mention that the particle is continuous. Okay? So I'm not going to write all of this out, but particle is continuous. I can guarantee you don't remember it, but we just, what'd you say? There's a theorem?
Yeah.
IVT. Yeah, so this is by IVT, intermediate value theorem. There are 3 values. And that was supported by my chart, right? 3 values when x of t equals 4. Okay? Now, C and D, do I have time? Okay. C. On what interval is the speed of the particle increasing?
Same signs. Opposite was slowing down.
Oh, so then same
So
speed.
same signs is increasing.
Right. Same signs between basically velocity and acceleration is increasing. Opposite signs is decreasing. So here, what do we have? Speed. It actually happens on 2 intervals.
Would be 3.
Oh wait, actually 3 intervals.
Because there's the one at the end.
Yeah. 'Cause
Yeah.
what, 3,
There's actually, whoops.
6.
There's 3 intervals because we're looking at the speed is increasing and velocity is increasing from 9 to 11. Which was right here. Okay. And then we also have 3 to 6. They're both decreasing, and 13 to 15. They're both decreasing. These pieces sound familiar? Okay. How do I want to write that all out in like 0 time? I don't. So I'm shorthanding this, so I'm going to say 9 to 11 because velocity is positive and increasing. And then 3 to 6 and 13 to 15. And that right there is because velocity is, whoops, negative and decreasing. Okay? And one last question. Oh, acceleration positive? Oh my gosh. Acceleration is positive when?
6 to 13. Or what number? 11.
6 to 11, right? Because acceleration is the slope of my velocity graph, and so 6 to 11. So acceleration is positive when velocity is increasing. So basically when v prime of t is greater than 0, and that was 6 to 11. Okay. I think we should have gotten started quicker today. I was kind of slow on the roll, and that kind of backfired. Sorry, guys. Allow time for homework. It will take a little bit. These problems, like I demonstrated in class, they take a little bit to think through. And for me, it was even when I was doing it on my own. So